When we're looking at rates of change, a rate is when time is moving on, time is moving forward, and things are changing. Time is our big focus here. Time moves and things change. So imagine spilling some ink on some paper. You could say that as time goes on, the radius of the ink blot gets bigger, or you could even say the area of the ink blot gets bigger. Both of those things are happening as time changes. Okay, now the bottom of this triangle, the top will always be time, the bottom of this triangle you do on your own. You connect up the area and the radius. If it's a circle, that would be area equals pi r squared. You do that on your own, Toblerone on your own. And also, Toblerone is a triangle, so you remember to write down this triangle. You've got time at the top, and then you've got your two things that are changing, that are connected, your area and your radius, and you do that connection on your own, and then you can differentiate it really easily on your own. Now you're going to be given some information about one of the rates of change. You might be told that the rate, that's rate there, the rate of change of the radius is something like 140 centimetres per second. It's massively growing, this particular ink blot. And then the question is, what is the rate of change of the area? What is dA by dt? Or similarly, maybe we're given some information about dA by dt and we're asked about dr by dt, but one of the sides of the triangle, one of the sides on the diagonal sides you will be given, and one side you'll be asked for, and at the bottom you do it on your own. You connect up these two things yourself and differentiate that yourself. Now, once we get to this point, all we need is the chain rule. We want dA by dt. The chain rule tells us that this is equivalent to dA by dt going via round our triangle. Instead of just going straight between dA and dt, we can introduce the radius and go via the other two sides. So we can introduce dr like that. And the chain rule tells us that these are going to be the same. This is dA by dr, dr by dt. Now the thing is, going around my triangle, I know both of these. dr by dt I was told in the question. dA by dt I did on my own. I did it on my own, and I got dA by dr is 2 pi r. So let's feed them into this expression. dA by dr is 2 pi r. dr by dt is 140, and I'm done. I've got my dA by dt. If I know what the radius is at a specific time, then I will be able to find the rate of change of the area at that time. Let's try this example. We'll set up our Toblerone triangle, and then we'll do the bottom on our own. At the top, we've got time. What are the things that are changing here? We've got the length of the cube, the length of a side of the cube, x, and we've also got the surface area we're interested in, surface area. Okay, we're going to do this on our own, this bottom bit. Toblerone, do it on your own. So, surface area of a cube. Well, each side is, actually I might just call it S for surface area, not SA. Each face of the cube has an area of x squared, and there are 6 of them, so the surface area is 6x squared, and then we differentiate. ds by dx equals 12x, and we did that on our own. Okay, what information are we given in the question? We're told that the rate of change of the length, so that's d by dt, that's rate of x, the length, is equal to 8 centimetres per second, and we are asked about the rate of change of the surface area. We're asked about the rate of change of the surface area. So we use the chain rule. ds by dt is equal to, and we go round the other two sides of the triangle. So instead of just going straight between s and t, we go via x. So we introduce this dx. Then we look for the information which we've got. ds by dx is 12x, dx by dt is 8. So ds by dt, which is the rate of change of the surface area, is 96x. So if I know that at a particular time the length of the cube is 3 centimetres, then I know that the surface area of the cube is increasing at a rate of 96 times that length. Let's try this one. So we've got our Toblerone triangle set up, with time at the top, and the two things that are changing are the radius r of the sphere and the volume of the sphere. So you can think of it as like blowing up a round balloon. The radius is increasing and the volume is increasing. Now the bottom bit we're going to do on our own, this bit. So what do we get? V, the volume of a sphere, is equal to 4/3 pi r cubed. You should probably know that one. So let's do this on our own. dV by dr is 4 pi r squared. We did that on our own. Okay, we are told that the radius r of the sphere is increasing at a rate of, oh, that should say to the -1, 4 centimetres per second. So the rate of change of the radius, the rate, so it's t on the bottom, the rate of change of the radius is 4 centimetres per second, and we are asked about dV by dt at a specific time. So using the chain rule, dV by dt is equal to dV by dt, but going via r. dV by dr we know is 4 pi r squared. dr by dt we know is 4. So dV by dt, the rate of change of the volume at a certain time, is 16 pi r squared. So when r is 10, at that specific time when r is 10, dV by dt will be 1,600 pi centimetres cubed per second. What if I now change the question slightly? And what I'm going to do is I'm going to take out when r is 10. You're probably thinking, well, that just makes it easier, I don't have to stick the 10 in. And I'm going to change it to in terms of v. Okay, now let's have a look at what we've got. We've got dV by dt is equal to 16 pi r squared. Now that is not in terms of t, that is clearly in terms of r. So what we're going to do, and this is why this own bit of the Toblerone is really important, because it connects the two things that are changing as time changes, the v and the r. So if I want my dV by dt to be in terms of v, all I have to do is take this bit that you did on your own and rearrange it. So I'll get 3/4v equals pi r cubed. Keep going, divide by pi and cube root. That gives me, running out of room, 3/4 pi cube rooted v equals r. And then this can go in here. So dV by dt is equal to 16 pi, and then we've got 3/4 pi v, and we've got it cube rooted and also squared. And there you have dV by dt in terms of v.